Ever wonder what your smartphone and, say, your toothpaste have in common? Well, they both started their lives buried deep inside the earth. Today, we're going to dig into the hidden world of minerals, the raw materials that literally make our modern lives possible.
Okay, so let's start with something you probably used this morning, your toothpaste. It seems so simple, doesn't it? Just a paste in a tube. But that little tube is actually a marvel of geology and engineering.
So the abrasive stuff that does the actual cleaning, that's minerals like silica and limestone. And the fluoride that helps fight cavities, that comes from a mineral called fluorite. The brilliant white color, that's titanium oxide. Oh, and if your toothpaste sparkles, that's thanks to mica. And get this, even the plastic tube it comes in is a product of petroleum. It's pretty much a mine in a tube.
And it's not just toothpaste, of course. Just look around you right now. Your phone, the roads you drive on, the building you're in. They're all built from minerals and powered by energy dug up from the earth. They are the fundamental, absolutely non-negotiable building blocks of our entire civilization.
So, how in the world do these materials get from deep inside the Earth's crust all the way into our homes? Well, that journey is a super complex process that involves geology, massive engineering projects, and the whole global economy.
Right, so minerals don't just exist in some pure form ready for us to scoop up. They're found in something called ore. Just think of ore as rock that's especially rich in a certain mineral, so rich that it makes the incredible effort of mining it actually worth the cost.
And these ores, they show up in different geological formations. Some, like copper and zinc, fill the cracks in ancient superheated rocks. Others, like coal and iron ore, are found in these huge layers, built from sediment that's been compressed over millions of years. Then you have bauxite, the source of aluminum, which is basically what's left over after surface rock has weathered away. And of course, precious metals like gold can be found washed down into the sands of valley floors.
Now, to make this a little more real, let's look at bauxite, the ore we use for aluminum. In India, a mind-boggling 65% of all production comes from just one state, Odisha. This just goes to show you how the world's mineral wealth is really concentrated in a few key places, giving those regions immense economic and, frankly, political power.
And just as not all regions are equal, not all ores are created equal. Take iron ore, the very backbone of industry. Magnetite is the premium stuff, with up to 70% pure iron. Hematite, on the other hand, is way more common, but has a much lower yield. The quality of that ore has a direct impact on the cost and efficiency of absolutely everything that follows.
But finding and identifying these ores, that's just the beginning. Getting them out of the ground is a massive undertaking, and it comes with a pretty significant, often hidden cost, not just in money, but in human and environmental terms too.
It's a question that really makes you stop and think, right? The conveniences we all take for granted, our cars, our phones, our homes, they're all built on the immense and often really dangerous efforts of miners working deep underground or in these vast open pits.
You see, the reality of mining involves constant, serious threats. For miners, there's the risk of collapsing roofs, fires, and lifelong lung diseases from breathing in dust. And for the environment, we're talking about contaminated water, degraded land from waste, and polluted rivers. This is the hidden price of our modern world.
So what powers this huge global machine of extraction, refining, and manufacturing? What fuels this mineral-hungry world? Well, the answer, of course, is energy. A whole lot of it. Broadly speaking, we get that energy from two types of sources. You've got your conventional ones, the finite fossil fuels we've relied on for centuries, like coal, oil, and natural gas, and then there are the non-conventional sources, the renewables, like solar, wind, and tidal, and these represent our path to a much more sustainable future.
For now, though, conventional sources are still king. In a country like India, for example, coal isn't just a source of energy, it's the main engine of the national economy. It powers everything from heavy industry right down to the lights in people's homes.
But a new energy future is definitely on the horizon. As a tropical country, India also has incredible, almost untapped potential for solar energy. This is a massive opportunity to shift the balance, to cut down on environmental impact, and build a cleaner energy system for everyone.
And this shift isn't just some nice idea, it's an absolute necessity. Because here's the hard truth. Our planet's resources are not infinite. We are using them up way, way faster than they could ever be replaced. I want you to let this number sink in for a second. 1%.
The total volume of all the mineral deposits we can actually mine and use makes up just 1% of the entire Earth's crust. It is an astonishingly tiny fraction.
You know, the geological processes that created these rich deposits took millions of years, and yet we are consuming them at a rate that is, geologically speaking, the blink of an eye. The replenishment rate is basically zero compared to our demand. So what do?
Well, we have to get much smarter and more sustainable in our approach. This means we need a huge effort to recycle metals, to use scrap, and to develop new tech that lets us get value from lower-grade ores more efficiently. And wherever we can, we need to find sustainable substitutes.
And this idea right here is probably the most powerful tool we have. See, conservation isn't just about using less. It's really an act of creation. Every single watt of electricity we save, every resource we recycle, that's energy and material we don't have to pull from our finite planet. It's the cleanest and cheapest source there is, bar none.
Which really leaves us with a final thought. We know the Earth's pantry has a bottom. The geology is what it is. The real question, the one that matters, is about us. Is our ingenuity finite too? Will we be the generation that finally learns to live within our planet's means, or will we be the one that uses it all up? The choice and all the consequences that come with it are ours.